learn how to use NVIDIA ROS. Okay, let's try again. So want to learn how to use NVIDIA with ROS? So today, here we are going to explore how to do that. We are going to provide you with some code that is already done, so you will be able to use it. And also you will be using a simulation so you can practice online. So let's start. This is the ROS Developers Live class. Hello ROS developers, how are you doing? Welcome to a new ROS Developers Live class. We are going to try to recover from the disaster of the last live class that we have a problem while we were trying to execute the code that we promised to you. So let's see, we have worked very hard along this week. As you can see, we have improved a lot of the aspects of the ROS Developers Live class, and more are about to come in the next weeks. So expect for that. And yeah, so now it is time that we start with this subject that is super interesting. I have been talking with some of the people on the chat while prior to the live class, and many people is using NVIDIA Nano or are planning to use NVIDIA Jetson Nano with ROS for very interesting project. Have a look on the chat that is beside here, and you will see the discussion that some people were pointing about experiments and things. So I would like to say hello to most of the people that are there on the chat. For example, we have a Gianfranco who has arrived. Roberto Guzman, oh, nice to have you here. Roberto is the CEO of Robotics, an amazing company about ROS. They sell a lot of robots of ROS, and we buy our ROS components at their company. So we have no commission for that, just we like their shop a lot. Then we have Burke here. Hello, how are you? Saktibel, who was here last week. Also we have ROS Agriculture, Matt under that name, and then we have other people like Lucas. Lucas is one of the guys, I think that you are the guy who are going to come to the Mastering ROS course that we are going to do at the end of February in Barcelona. It's a live class, it's a live course actually. It's a week long, and there we are going to teach how to use big mobile manipulators, including navigation and arm control and so on. By the way, the robot that we are going to use there is being created by Robotics, by the company of Roberto, and they have allowed us to use it. So we are preparing this in collaboration with Robotics. And many people there, also Martin Nieves, Carlos Cristomo, and then we have Burke, already mentioned, Brian Muguet, Fico Timon, Marcus Ducol. Marcus, always supporting us. Thank you very much for being here. And so many people, Brian Mogret. I cannot say hello to every one of you. I have a new screen here on the side that we are trying to do this to separate the ROS stuff on the computer and then the emission things on the other computer, so I can have some separation and my brain can work better. You know, okay, so let's start. I see that you are asking a lot of things there on the on the chat, but I cannot attend right now. Too many things. Then let's do one thing. Let's start by explaining how this is going to work, because I have a lot of people here. Many of you are new people. So let me explain how it works. So what we are going to do today is to learn about a very specific subject. It's about using NVIDIA with ROS, NVIDIA Jetson Nano. And then where we are going to start is by sharing with you a ROSject. That is a ROS project that contains code, documentation, simulations, all the stuff that we are going to use today here in the live class. So I'm going to share this. I'm going to start by sharing this with you on the chat. So you can see that there is the video window, and then on the side there is the chat. And there you can ask your questions. And also I'm going to share there a link. By clicking on this link, you are going to get access to that ROS project. It's for free. And it's going to redirect you to the ROS Developers Development Studio, which is a web environment where we can practice ROS online without having to install anything on your computer. So it doesn't matter which computer you have, which distribution of Linux or Windows or Mac or whatever you have, because it's going to be everything executed on the web. So don't worry. And you don't need to take any extra step. Then I'm going to share this, and then I'm going to teach you step by step how to continue, how to do all the stuff that we have prepared here. So you can see on the video, and then you have to follow my steps on your own screen. Okay, so basically that's the procedure. Then, having mentioned this, let me have some coffee on this super cool mug that I have from ROS 2. Still hot. Great. And yeah, so we are going to work today with this robot, both simulated and real one. But before starting into that, let's start by sharing the ROS project of today. So you can start launching, because this is a big ROS project. It's about 1.4 gigabytes. So it's going to take a little bit to start, to open. So let's start by sharing it, and then we can continue chatting, and then I can have a look there on the questions on the screen. So let me share with you the screen, my screen. So let me share. Here I have. And what do I have? Okay, so I have already opened the ROS yet, but let me go to the list of my ROS yet. And this is the one that we are going to use today. So this is the ROS Development Studio, which is the tool that we are going to use for learning about ROS today. I have many ROS jets, as many as 200. And today we are going to use this one. So I have created this with the help of Miguel Angel, who is another member of the ROS, of the construct. And so I'm going to share it with you. So how do we share a ROS jet? Very simple. I click here, and then I copy the link, and then I paste the link into the chat. So I'm going to the chat here, and I'm going to share that with you. There it goes. So now what you have to do is just go to this link that is on the chat, click on it, and then it will redirect you to the ROS Development Studio and create a copy of this, the same as I have here. So you will see this image, this title, this configuration, etc. So I hope that you don't have any problem on that. Alberto is helping me with the questions on the chat, so don't worry if I cannot answer personally the questions. I will try anyway, but if in case that I cannot, Alberto is there to support you. So don't worry, okay? The purpose of this live class is that you learn a lot. So I want you to learn a lot here. So if you have problems, if you get stuck, don't panic. Don't just say, oh, that's I don't follow. Just ask the questions on the chat. We'll try to do our best, okay? So take into account that we are a lot of people. We are about to be 100 people here, and then that's a lot of people from different countries around the world. Then we'll try to do our best. But please put your questions if you get stuck, you have a problem, and we'll solve you. I want you to follow with me, okay? So you have to follow, you have to practice, because the way to learn ROS is by practicing. If you don't do that, then just watching videos or reading books is not going to make it. So here is a place where you are going to practice, and you have the chance to ask, okay? Related to the questions, sometimes people ask questions about other subjects that are not the live class. Okay, so we can answer those, but it's not possible within this framework, within the live class, because we don't have the time. I mean, we have 1 hour and we have to go to the subject. Yeah, I'm sure that you can understand. So post your questions on the video comments and so on, and we'll answer those. Okay, so I think that most of you already have the ROS Jet already. So let's go back again and let's go to the opening the ROS Jet. So how do we do? In order to open, you just press here open, and then this window is going to show where you have to select the hardware that you would like to launch. Then in your case, if you are just a free user, then you will have to select basic one. It's 2 CPUs with no GPUs. Okay, so you have to select that one because this is the layer that we have for free. In my case, I'm going to select the Pro one only for today. Okay, usually I use the basic also, but today I'm going to select the Pro one because it has a GPU. And then I want you to see the difference between using GPU, no GPUs, or using GPUs. So in your case, you are going to be able to launch everything and run everything. Don't worry. The only thing is that it's going to be a little bit slower. Okay, so that's the only drawback. But it's going to work for both cases, and I want to show you also how it looks with the GPU. In the GPU is in the place where we get some money back in order to sustain this business. Okay, so then there is Pro 2 with more GPUs, more CPU. That's for more advanced projects. So let's go select the one and then press Open ROS Jet. By doing this, then the machine is going to start. You are going to see one screen like this one, and then it's going to load everything. First launch the machine, then load the project, and it's going to take a while, some minutes. So in the meantime, let me just go here and talk to you about the robot that we are going to use. So what is this project about? This project is the one about this car that is the NVIDIA Jetson Nano. And then we want to do experiments with that car, and for that we have created this robot that you can see here in the table. So we call the IgnisBot. Yeah, I know. I think that the people that decided the name for that day didn't have a good breakfast. But yeah, that's the name that we are going with. Thank you very much, Johan, for that. And then anyway, so that's the robot. So what we have done is to take a JetBot as a basis. The JetBot is something that you can buy. I'm going to show you more details on the documentation in a minute. So we bought this and then we modify in some way in order to get some covers, as you can see here. So I'm not going to put it right now, I will show you later. So then we have also included this camera with a servo. So that has a servo that can move up and down in order to detect people. We want to make the people detection with the camera. And then also on this side, we have added, this is a kind of a queue of a tail, sorry, not a queue, false friends in Spanish. So it's a tail that we want to use this as a device that can provide us with some feedback from the robot. So by using this configuration, we can use the robot as a dog, let's say as a dog. Okay, so you can see here on the camera, let me see, like this, yeah, more or less. So it is running at present, so I have switched it on. We have here a button for switching on, and in the cover there is a hole that you can switch it on and off. Then also we have included here this I don't know, you can see a little bit, is this a screen. It's a very little screen that provides some useful information like the IP of the robot in the network that has connected. That's very useful because then you can SSH to the robot. And yeah, that's it basically. So that's the robot that we are going to use. So first here we are going to use the simulation all together, and then I will show you a little bit how to execute in the real robot, connecting directly from the web environment. Okay, so let me see if there is any question here. In my case, the ROS Jet has already opened. Let me know if it has opened for you. So I'm going to share the screen here with you. Then This is my ROS jet that has opened just like that, like this, and it should have opened like this for you. Okay, so then here, this is the Jupyter notebook, is the one that contains the documentation, and it opens automatically, and here it contains all the subjects that we are going to cover today. Yeah, so this is by default. In case that you close it, don't worry, you can reopen by going to the menu tools and then select Jupyter notebook. You will get the notebook there, and you can select that notebook or another one and just open it. Okay, so far so good. Let me see on the questions if there is any question that I have to deal. And then I see that Miguel Angel is also answering some questions. He's one of the creators of the IgnisBot, but basically the main creator of the IgnisBot, and also one of the creators of this notebook. Thank you, Miguel Angel, for all your help and support. So then let's go with the notebook. Okay, so you can follow on this notebook with me. Then this is a ROS jet is what you have opened right now, and then it contains, as I mentioned, documentation, code, simulation. You can see all the files of this if you go to Tools and then select IDE. Then you can see here, let me move it on the side and make it bigger, for example, like this. You can reconfigure, you can play with the icons later and see how you can reconfigure everything. And yeah, so you will see. So here we have several workspaces. We have one with the notebook. This is the one that contains the default notebook. Then we have another one with the simulations, that here we contain the IgnisBot simulation. Then we have the Catkin workspace with the code that we are going to use today here, that is about the people follower. Yeah, and also you can include data sets. In this case, we have none, but it's okay. So for today, that's what we have. And also there is another one for the web page, where you can create web pages for controlling the robots from the web pages. That's very interesting. Another one for AI results. Well, that's it. So that's a ROS jet. So every time that you share a ROS jet, you are sharing all the content of this, and you can download to your local computer. Okay, so it's just right click and then download, and that's it. Then it will download the directory with the packages, no special format that you have to take into account. So what is this ROS jet for? It's for working with NVIDIA Jetson Nano. And why? Because we want to do some experiments. We want based on deep learning, and we want to do them on board the robot. So we can do experiments, of course, using the cloud and using the high CPU, high number of GPUs in the cloud and so on. But in case that you would like to build something that is autonomous, that everything is running on board, and you want to use deep learning, then NVIDIA Jetson Nano is perfect, because it's super powerful compared with other like Raspberry Pi or similar ones. So really recommend you to use that one. Well, that's the main problem, the main subject that we are dealing here today. Then, okay, let's make this larger. Oh, yeah, so continue. Yeah, what is, oh, get out. Okay. Yeah, so this is the IgnisBot, is the one that we have created, as I have mentioned to you. Then our goal is that you also build this robot for yourself, so you can do all the experiments. So the design of this robot is open source. Everything that we have done, from the modifications to adding servo motors, to also the 3D printing models, everything, you can find it here in this link, and you can build the robot by yourself. So we have built this in order to do many different experiments and use this robot for ourselves here at the construct, for testing ideas and preparing new courses and doing interesting stuff in something that we can use very easily. Then the idea is that you build this for you, and you also you also practice with NVIDIA, with CUDA, with deep learning and all that. So we are providing here two versions for you. The first one option is the bill of materials. This contains everything, including the 3D printable files. And so you can buy, there are some links here to buy on Amazon, and you can use those to buy by yourself everything and then build it yourself. So that would be great. In case that you don't want to deal with all that and you just want to order that for us, to us, and then you receive everything already ready just to assemble, then here we provide it also. But it's not necessary at all, okay? So you can do it by yourself, buying the parts and by yourself. And here you have complete details about how to assemble, even about how to print it. So we have created this video assembly guide that you can check, and and look for the details. If you have problems, of course, contact us and tell us. Okay, so that's the old page that I was using. Great. So what does this ROS Jet contain? So in order to work with the deep learning, we are going to use TensorFlow version 2, and that requires to use Python 3. And as you probably know, there is a big problem using ROS with Python 3 because ROS works with Python 2 by default, the ROS classic version. So up to now, at Melodic, it works with ROS with Python 2. So we had to create a Python 3 environment and then activate this and prepare all the packages on that Python 3 environment. So this is already prepared. Now, I have received a lot of questions or requests from people telling us how can I set up my Python 3 environment in my ROS setting. So because so many people is asking about that, then we decided to do a live class just to teach you this, how to set up a Python 3 environment to work with ROS. And it's going to be on the 11th of February. So that class on the 11th is going to be about teaching you how to create your Python 3 environment to work with ROS Classic, not with ROS 2. ROS 2, you probably know that already works with Python 3 by default, so it's not necessary. Okay, so having said that, then let's continue. This ROS Jet contains the pose estimator, which is the package that takes the images from the camera and then creates identify where is the person, and then publishes this information about where is the position of the person that has detected. Then we have included this people follower. The people follower is the program that takes the information from the pose estimator, and then so the one of the previous module here, and then uses that information to generate the command. So the command wheels to say the robot to which direction to move, and also to move the camera. As I mentioned, the camera can tilt, and then the camera is going to adjust based on the height at which the face of the person is, or the shape of the person is. Remember that this robot is a small robot and it is supposed to work on the ground. We are going to use that on the ground, okay? So you are going to see in a minute. So we have the pose estimator is the one that is getting the images and making the deep learning thing. And then the people follower is the one that takes the results processed and provided by the pose estimator and makes the robot behave in the proper way. That is to follow us. So to find a person and then approach it and then wag the tail if it is close. And also the tail is going to wag at a certain frequency based on the distance to the person. So if the person is very far, it's going to wag a little bit, and if it is closer, it's going to wag a lot faster. Also, the robot is going to wag the tail only when it detects a face. Only if it is detecting a face. So if it is too far, then the face cannot be detected, and then it's not going to wag the tail. That's it. Okay, so let's start by launching the simulation and launch this simulation that we are going to use of this robot, of the IgnisBot. So for that, the simulation is included here, and you can launch it from a terminal, but we are going to use a simpler way, which is using the menu here, that is the simulation menu, and then choose launch file. If you choose the launch file, then here you can have, in this menu, you have a drop-down menu, and then you have to select from the package that is called jet_gazebo, you have to select the main IgnisBot Lite. Main IgnisBot Lite. Yeah, well, as you can see, we are very funny with the names. You know, this is done in order to prevent confusion, you know? Okay, just joking. Miguel, don't worry. Don't get mad at me. Sorry. And then once you have selected that, press launch. Then the simulation is going to appear here in another window. Okay, you can tell me, oh yeah, but how do I do in my local computer if I have downloaded? Yeah, no problem. You can do it also here by doing a ROS launch. And then ROS launch, what is? Name of the package, jet.gazebo, and then name of the launch file, main IgnisBot Lite launch. That's it. That's it. If you do that, it will also work here. How can you do that here? Very easily. Go to Tools, then open a shell, select a shell, and then type the command. Then if you type the command here, if you type the command ROS launch, blah 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 blah, ROS launch, IgnisBot Gazebo, IgnisBot Gazebo, then Gazebo, IgnisBot Gazebo. Cannot autocomplete. Oh, sorry, IgnisBot. No, it's JetBot. JetBot Gazebo. JetBot Gazebo. And then JetDog. Okay, JetDog Gazebo. Then main IgnisBot. Main IgnisBot Lite. So if you launch this, I'm not going to launch it, okay, because I already have the simulation here. It's going to collide and crash. So if you launch here, the simulation is going to be launched, but this window is not going to appear by default because this is a web window, okay? So the gazebo window is not shown by default here. So if you need to watch to get this back, so once you have launched it, you can go to Tools and then select Gazebo. By selecting Gazebo, you will be shown this screen. So for example, if I close the screen, oh no, if I close, it's going to close the simulation, but so whenever you need to get this window of the Gazebo simulation, go to Tools and then select Gazebo. That's it. That simple. Okay, so we have the simulation here. And what do we have? We have a person that is more or less well-defined, this person here, and then another one that is just a shape. This we have created this just to show you the difference between when the people tracker can detect a person without a face or when it can detect a person with a face. So you can see the difference, what I mentioned about wagging the tail. So even if the person is detected, so the robot is going to approach, but it's not going to detect the face, so not wagging the tail. So it's kind of a human detector. We can use it as a human detector, yeah. So then we are going to try with both of them, okay? So let's go. So we have this simulation running, and then as I mentioned here is the part of the demo that we are going to make it work. Let me have some coffee, and let me know if you have any questions here so far. Let me know. Do you have any problem? Are you following? Were you able to launch the simulation? It's probably that if you launch the simulation, you got here the 100% in the CPU. That's, don't worry, okay? Don't worry. Just press OK, and that's all. This is just, we are telling you, because the higher the CPU, the slower the system is going to go, but it is working. So don't worry, because you can follow everything. We have tested everything with this kind of computer, of course. Okay, so far, any question? No questions? Everybody is following? Okay. Yes, great. Okay, I see here one question from Gada that I think is being not answered, that says, how can we participate in the Python 3 course? Oh, I presume that you are mentioning about the Python 3 live class that we are going to do. Is just come. Just come. It's on the 11th of February at this same time on this same channel, the Construct channel. So you will see that there is an announcement in our YouTube channel saying, hey, here is the live class. Just then connect to the video and that's it, for free, of course. So that's it. Then we have here people, Bird, that say so far so good, great. Lucas also, all good. Carlos Cristomo, yes, trying to launch the gazebo sim. Okay, Carlos, let me know if it doesn't work. And then Ali just arrived, looks like, says, hello Ricardo, nice to meet you. My pleasure, Ali, to meet you, of course, you are welcome. Go, if you just arrived, go very quickly up into the chat and grab the ROS Jet. Click on the ROS Jet and start practicing with us, open it. Ask your colleagues on the chat to help you on that. Okay, so now we have this system running that is the simulation of the robot that I have on my table, as you can see. And then let's start by activating the Python 3 environment. Sorry, I didn't explain to you the 3 parts of the demo. So we have these 3 parts that is, I have divided this into 3 parts, 3 main parts, the important parts. The ones that are the interaction between the deep learning NVIDIA stuff and the ROS stuff. So we have first the pose estimator. The pose estimator is a software that is the one that it's doing the deep learning, okay? Is the hard guy here, the tough guy in this demo, is the tough guy. And it's not being created by us. So it's been created by another guy who the credits are down, and the package is called the TRT Pose, and it's already installed on the system. In case that you would like to install it, then here you have more information here about this is the people tracker, and you can get the original stuff here and then install it. Okay, so you don't worry that you have all the information here to do it by yourself. This is an introduction, and then we have to guide you and provide you some stuff already done in order to advance. Otherwise, the live class will be 3 hours or 4. So then it is already installed in our Python 3 environment because it works with TensorFlow number 2 with Python 3. Then we have the people tracker. The people tracker is the one that gets the data from the pose estimator and then publishes the ROS data of the poses. And you can get this code. It's already provided to you. We are not going to follow here. It's too much, but you already have it done in this package. And it's this specific Python file. And then you have also this is the people tracker who publishes data of the poses. And then we have the people follower who takes those poses and uses it to convert those positions related to the robot and into real commands. So you can find the code in this file, people follower and IgnisBot people follower package. So in order to access this, you need to go to the IDE. Remember that to go to the IDE, you need to go to Tools and then IDE. That's complicated. That's complicated. Yes. Then you have all those workspaces. And where can you find those? Well, it's very easy. If it is something related, so look at the configuration of those workspaces. If it is something related to the simulation, something related to IgnisBot simulation, then it has to be on the simulations workspace. If it is something about the code that would run inside the robot, then this is going to be inside the Catkin workspace. Okay, so those packages should be here inside the source, Catkin workspace, source, my Catkin, and then source. So you will find them here. Okay, IgnisBot, ROS people follower, Yeah, and then inside here, so the Python files that we have mentioned inside the script. You can also use the typical ROS cd commands to get into there in the terminal. Okay, so far so good. Okay, so now let's go and let's launch things. We want to launch things and get the robot move and do things interesting, deep learning. Yes, we want to do that. So let's go. How do we do that? First, we are going to activate the Python 3 environment, and this is already installed. Okay, so this is already installed. So here are the instructions for activating this. It's already installed and already prepared. So what we are going to do is, first, we are going to go to our directory where we have our packages. So this is the first command. So you can copy or just type it. I copy and paste from the notebook directly. So what I have done is to go to my Catkin workspace Python 3. Here is where I have my, inside the source. This is a Catkin workspace that has been prepared. So it's, well, actually it's going to be compiled with Python 3 activated. Okay, so it's still not compiled. Actually, yes, it has been already compiled, but we are going to compile it also. So this is our Catkin workspace that we are doing with Python 3. So now let's activate our Python 3 environment. So for that, we have to copy this line, which is source. Then in the home directory of this project, there is another hidden directory that is called Py3 environment. And there we have the activate command to activate this Python environment. If you don't understand this command and what is the result, then, okay, don't worry. Then you have to do the course about Python basics, Python for robotics that we have. It's a free course. I will show you later where it is. Then what we are doing here is activating a Python 3 environment, virtual environment. Okay, so now this terminal, it's been activated with Python 3 on it. Okay, then we are going to source and okay, wait a second. Okay, so so we have activated that one, and now I don't remember why we have to activate that one because it's already activated. Actually, we should activate, it's not correct, that one, so it should be like this without the dot. Home user, and actually it's actually not even like that. It's Catkin workspace / source. I think that this is an error that we have, and then we have to activate this Python 3 ROS workspace that we have. So yeah, so we have to modify in this way. So we have to source actually the setup devel that we have in this Catkin workspace of Python 3. And then in order to prevent errors from this long command that I have just modified, let me show you a better way of doing it. So you have to, here in this Catkin workspace, if you do an ls, you are going to see this devel directory. Basically, this is this devel directory here. So let's source the setup file, setup bash, that we have on that devel. So for that, we do the source of devel / setup.bash. Okay, so now we have sourced we have activated the Python 3 environment. Then we have sourced the Catkin workspace, and now we are going to indicate to Catkin that it has to compile all the packages that we have here of ROS. Here, all those packages, we are going to compile them by using this Python 3 environment. So for that, we have to indicate here explicitly that it has to use this specific Python compiler from this Python 3 environment that we have activated. Okay, so that is the line that we have to execute, is the catkin, blah, 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 blah. You have everything there on the notebook. Then you issue that command, and then it's going to compile everything. Actually, it's not compiling anything because we already provided everything compiled for you, but we are showing you how it should be. Then let me here. Okay, so once we have that, then let's source again for the results. Just in case that we have modified something, this is the typical procedure when you are compiling. So do the source again of the devel setup, and we do a ROS pack profile just in case that we have created another series of packages to be discovered by ROS easily. Okay, so far so good. Then we have compiled our packages that we have in our Catkin workspace with Python 3, and we are ready to launch it. Then in order to launch them, we have two options. So you can launch the people follower by using CUDA if you have a GPU machine. If you have launched this ROS yet with a Pro 1 or Pro 2, you have some GPUs running. Then this is the option that you have to use. In case that you don't have, here you can buy extra credits here on the ROS Development Studio. So this is the way that we make business here. So that's why we are putting this here. Okay, just if you want to support us and then you need to do some experiments, then try to experiment with our platform using CUDA with those packs. But it's not mandatory, okay, for what we are doing here. Then in case that you have CUDA, then the command to launch is this one here. So we have prepared two versions of the launch file. Then in my case, I'm going to launch the first one, of course, because I have selected CUDA at the beginning. So this is my launch file. In case that you don't have, that you have launched the free account, then launch this one. And this one is going to execute everything using the CPU. Then the only problem is the speed, okay? So don't worry. Then let me launch mine, and you should launch yours. And then we should see, by launching, it's going to take a little while, but by launching this, you should see that the robot is going to start moving. It takes a little while, okay? Even in my case, you are going to see that it takes a little while. Okay, here goes the robot. But what is doing? It is rotating. Okay, it is turning towards this person here. You see, it's kind of moving into that direction. How can we see what it is seeing and processing? So by launching this launch file, we are executing this application also that will tell us about the structure of the person that has been detected. Okay, so how can we access this window? So in order to access, we have to go to graphical tools, and then actually we have to go to tools and then select graphical tools. So we go to tools here, menu, and then select the graphical tools. Then a new window is going to open where you're going to see any graphical application that appears here. That should appear here. And okay. So I cannot see it. I don't know if something went wrong. Oh, okay. So sorry, it still hasn't. Yeah, okay. So still it is loading still. So yeah. So what happened here is that the control program has started faster than the tensor, than the pose detector. Okay, in my case also reached the 100, almost the high CPU, so it's telling me that I'm using a lot of CPU, but you can just click, if that is your case, you can click dismiss, and that's all. Okay, so here is still loading, okay, so it takes some time at the beginning, on the first time. So it's still loading, and we don't have the model here yet, so it should appear a window like this one. It is because it is starting yet. Okay, so it takes a little while. So in your case, are you launching this here? Then the robot is not receiving any input from the model, so that's why it's doing kind of a random behavior. So let's wait until it launches. And let me know if you have any question in the meantime. Okay, we got some problem with the simulated camera, said that, but it's, yeah, okay, so it's processing, and I can see here that it's also working. So here we have now the window that has appeared, and then the robot has detected this person. Now, when you can see here that this is the detection of the person and how the robot is heading towards that person. And I think that I saw it moving wagging the tail. So it's already detecting the face. Even with this low quality of the image, the system is working. And then probably you will say, oh yeah, it's working because always it's working like this. But it's not true. So we can try afterwards with the person, with the other person that is the strange shape which resembles a person, and you will see that it doesn't wag the tail. And then the tail is wagging faster as it approaches the person. And then more or less, then it should stop at a certain position in order to stay away from the person until it moves away. So we can select, for example, the person and then click here on the arrows and move the person back. And once you have moved, in order to apply this new position, remember that you have to click again on this single arrow. Now it has applied, and then the robot is going to detect here on the camera that the person has moved, and then it should move again. It should. Or do something if it's not quite detected. Okay, so we have some problem. Let me put it closer. Oh, wait, I'm going to mess it. Okay, there it goes. There it goes again. Okay, I'm wagging the tail. Okay, so let me know if that works for you. Then in the meantime, let me connect now, do the same thing with the real robot. So we can execute this code inside the real robot, the robot that I have shown to you on the table right now. So I'm going to try to connect. So how do we connect with the real robot? It's by using this real robot connection here that we have, and it's an option. This is also a paid option. It's very low price. I mean, it's about €9 per month for this, so it's very affordable for anyone. But the thing is that you can connect the code that you are executing here to the real robot and then executing there in the real robot. So what I'm going to do is to connect. So I click here and then connect to the real robot. Press this icon here. And I'm going to close my program right now. Okay, so this I'm going to close because we don't need it. Let me know if you have any problem in the execution of that. Okay, on the chat, I see no questions. I see Roberto who is saying it works. Great, very good. And then I see, is someone else getting this error? Robot name equals person standing is not in model state. Trying again. Okay, where do you get that in the execution? Tiago, where do you get that? Okay, so then Carlos says that by restarting the simulation something. Okay, no, I don't know, doesn't make sense. In Gazebo you mentioned, Tiago mentioned is in Gazebo. Okay, so, but are you seeing the person and the robot? Then we have another question from Durga that says, while working with Intel depth cameras in Jetson Nano, I'm getting error. Could anyone help me? Yeah, but we cannot dedicate now the time for doing this right now here because we are in the middle of this live class. So please ask us a question on the comment section. And Tiago mentions that he's going to try to restart the simulation. Yes, please try. Okay, so I have pressed the real robot connection, and then I have robot name and robot URL. Okay, so how do I get those parameters? Those are parameters must be provided by the robot itself. So what we have done is to install the ROS-DS server into the robot. It's a very stupid thing. I mean, it's a package that has been installed there. And then once you install that on the robot, it provides a web page, which is this one. No, this one here. This one. So I'm now, as you can see, I am connected to the IP of my robot in my local network and through the port 3000. Then if you get this, then you can, if you get to that page into your own robot, then you will have those data. Here, the name of the robot is IgnisBot robot. So you can copy this and paste here in the connection, robot name. And then the other thing that you get is a robot URL, which is this one. So I'm going to copy and then paste here. So then I press connect. And then at some point in time, I should see here the robot connected. So what I'm going to do now is to close the simulation in order to prevent collision between the different ROS masters. You can select the ROS masters, okay? But it's just to simplify. And you can work with both things at the same time, but it's to simplify. So let me close it. So let me go here. It is trying to connect to the robot, and we'll see how it looks. So let me have some coffee in the meantime and check the questions. Then it should have connected previously. So let me do one thing. Let me disconnect this. Let me restart, okay? Because I was making some tests before, so maybe I left something open or something. So let me close this. So I'm going to close and then come here back to the robot. So this is the robot itself. This is a web server that the robot is publishing. So I'm going to turn it off. And that's it. So let me see if this is closed already. Still closing. Still closing. Come on. We tested. It has to work. Okay, that's done. Yeah, okay. Yes, finished. Okay, so now I'm going to repeat the process. Okay, so connect to the robot. Then here in the robot tab, I'm going to turn it on. And I have the name. And I'm going to put it here as it appears, the robot name. There it goes. And then the URL. So let me copy and paste here. It's a very long URL. So connect. And now let's see if that is going to work in the real robot. Yeah, there it goes. Yeah, I probably left something open, and yes. So we close it, everything. Now, here you can select between the ROS master that you want to use. If you want to use, if you want to use the ROS-DS computer, is this computer here on the cloud, then that's it. Or if you want to use the IgnisBot robot, then you can. This is now the selected ROS master. So if we do here, let me close a terminal and open a new one. So if I do now a ROS topic list, then what I'm going to see is these are the topics of the real robot. These are the ones in the real robot, not the ones on my computer, on my previous computer. So then what I'm going to do is to launch the code that launches the people follower in this computer cloud, but uses the information provided by the robot itself. This is the topics that are published by the real robot, the one that I have on my table. Okay, so I'm going to launch it and then connect to the real camera and see what is happening here. So let me put it there, remove some space, put the robot like this. So let me launch it here, the code. So it's going to take a while, then it's going to launch the same kind of thing. Oh, okay. So we have a problem here. Let me see. Okay. Okay, yeah, I think, yeah, let me close this one and let me see if I have the other one. Yeah, I need to launch it with the Python 3 environment, yeah. So it was here for the... Let me launch it here and then launch again. Okay, no. Open post ROS messages not working. Okay, it's strange this. Let me see. Let me check the error here. Is Ignis people follower package. That is correct. And I have source properly. Let me check. Yeah, so I should have access. The open post ROS messages. Let me see if I am missing something here. Okay, let me see. I'm checking here. It is like this. It was like this. No, but it doesn't make any sense to me. Okay, so but let me. Yeah, of course not. Then let me see what I'm missing. Let me close that one. I already messed it up too much with that terminal, so I'm going to start it again and see if I can. The only thing that I need is just up to here. I don't need anything else. So I have sourced everything. I have activated the Python 3 environment, then sourced the packages that we have in there. Then next thing is that I'm going to launch the proper package that we have here. Okay, so let me see if I can launch it. Yeah, that's correct. No. Okay, so it's not finding open post ROS messages. Open post ROS messages, then issue. So they should, so I have already sourced it, so should find it. Okay, so for some reason I was not sourcing the proper thing, and then okay, so the robot is moving here. So yeah, I don't know. Wait, that it's going. Okay. Yeah, let me connect to the camera again so you can see the robot moving and trying to keep a position from my. Okay, so there it is. I'm taking. So the robot is moving towards me, as you can see, and it's moving also the camera. I don't know if you can appreciate it, but it's moving the camera. It's trying to keep a certain distance from me, and it's going to fall down. Yeah, because I'm approaching towards it. So wait. It's because I'm a little bit scared that it's going to fall down. Okay. Okay, well, you can see that is the so it is working on the real robot. So what is happening now is that we are launching. Let me close it because otherwise it's going to fall down into the. Yeah, Okay, great. So what we were doing right now is to execute the code in the cloud, but using the topics published by the NVIDIA board. So the NVIDIA board was doing, remember, of the 3 parts that I mentioned for the 3 parts that I mentioned. Let me show you. They are here. The 3 parts of what I cannot find them here. Yeah. Okay. So I'm going to show you. Here, it's that the 3 parts that are composed of this demo. So it was the pose estimator that was running at present on the robot because it's using the hardware of the board. So that one was running. Also the people tracker, we also run it on the board of the robot because it's the one that is publishing the topics of the important parts, so the positions of the person that are detected by the pose estimator. So all those topics are available in the cloud computer that is the one that is executing the people follower. This is the one that I have executed here. And then this one is seeing all the topics that the robot has. So that's why we can control it here. We could also do an SSH and connect to the robot and transfer everything to the robot and execute everything in there. But this was just a demo. So I hope that it did work for you. Then I would like to go to more questions on the chat. So just to let you know that this is all for the class. You have everything here working. So you can check the code, you can check the simulation. You have a lot of value in this ROS jet. Really, it took a lot of time for us to figure out. You know how it's developing for ROS. But if you want to know the details, how to do it, how it works, so we have created this NVIDIA ROS course. It's an online course that teaches you step by step how we did it. And you are going to learn about building your own robot, of course, how you can apply this to the people follower, and also how you can create a collision avoidance ROS system based on the CUDA. So, and it's trained by itself. So we explain everything in this course. Have a look if you are interested to know more in detail. And that's it. So yeah, that's a video that I have included. If you want to execute it here on the video, select the cell and then press run. So the video is going to be embedded here, and then you can afterwards play it. And it's about about this project that we have done. So you can see Miguel, who is the creator of the creature, and so on. Here some acknowledgements, because we couldn't build this by ourselves. We are relying on the arms of giants. And that's it. So let me go to the questions and let me see if there is any question, guys. Any question? We have a few minutes still. Then we have many thanks there. So Maroki, Jirai, Durga, very happy faces. Saktivel, very happy faces, very good. Jirai, put it down. Says, yeah. Yes, and Carlos, and any other questions that you are having, or I can help you. Then says Katama says the activate command not found, but other command were. Yeah, the activate is for the Python 3 environment. So if you are not there inside the Python 3 environment, virtual environment, it's not going to work. Don't worry about that. Then ROS Agriculture Matt, thank you Matt for being here, thank you. And Do Hopable, thank you also. Ibrahim, nice tutorial, hope that it worked. Then I don't see many questions there, so I think that we are going to finish here. Just to let you know that the next week we are going to talk about ROSBot. ROSBot is another robot made by a company called Usarion. And it's a very nice robot to get introduced into ROS. And we are going to show you how to program that in the simulator, how to use the robot, and also how you can, even at the end, transfer if you want to the real robot. If you want, not necessary, it's an option. So I wait for you. Then remember that on the 11th, we are going to have this Python 3 live class. So I hope that this live class, it's been a success. Well, I don't hope, I feel that it has been a success, so I don't have to do the harakiri. That, by the way, I have the knife there to do it. It would have been very painful. But thank you. We have solved the problems that appear on the spot. And that's it for today. Thank you, guys. Thank you. And see you around here. Thank you if you want to be a ROS developer. So that's the place, you know.